Yo, what's good, algebra fans? Welcome back to another episode of How to Algebra. Today, we're continuing our journey with the complex numbers, focusing on multiplying, simplifying fractions, and plotting them. When multiplying complex numbers, remember to use FOIL. And don't forget I squared is equal to -1. For simplifying fractions, multiply by the conjugate to get rid of that imaginary number in the denominator. And finally, when plotting complex numbers, treat them like points in the coordinate plane. Real on the x-axis, imaginary on the y-axis. All right, ready to master complex numbers and crush these math problems? Let's get it. All right, now that we know what a complex number is, let's see if we can multiply and graph these things. So let's see. So first off, simplifying, right? And when you're distributing and multiplying, because in part one, we just learned the basic multiplication. Here, this is double distribution, right? FOIL in a sense. So it's going to behave exactly how if it was an X, right? First, outer, inner, last. 6 times 6 is 18. Or 6 times 3 is 18, I'm sorry. 6 times -2i is -12i. 3 times 3i times 3 is plus 9i. And then 3i times -2i. So this is going to be a negative. Then 3 times 2 is 6. I times I is I squared. All right, combining like terms, we get that -12 plus 9 is going to be -3i. And then let's note that I squared is really -1. So this is going to be -1 times -6, so positive 6. Again, combining like terms, 18 plus 6 is going to be 24 minus 3i, which this is a complex number. Right, we have a real part and an imaginary part. All right, let's try it again. So this is an interesting one. Number 2. Okay, so notice we have 9 minus 7i times 9 plus 7i. All right, this is a very specific relationship right here. This is known as a conjugate pair. So when you multiply conjugate pairs, something interesting happens. So we're going to do it fully, completely, and then I'll explain afterwards. So 9 times 9, 81. 9 times 7i plus 63i. -7i times 9 is -63i. And then -7i times +7i is going to be -49i squared. Okay, combining like terms, +63 and -63, that's nice. And then I squared we know is -1. So this is going to be 81. Negative and a negative, right? This negative and this negative multiply. So they become a positive. This typically will always happen. So plus 49. So 81 plus 49. 130? Is that true? So 50 plus 80. Yep, 130. So 130 is our answer. Okay, so going back to multiplying conjugate pair. So the two middle terms, right? The 63i and the -63i, That will always happen when you're multiplying conjugate pairs. So really, all you have to focus on is the first, for sure, the first, and then the last. Right? If you bypass the other two steps, that's okay, because they're going to cancel each other out anyway. So when you're multiplying complex numbers, distributing, you can bypass the inner and the last. So just the firsts, or the inner and the outer in the FOIL process, right? So just the first and then the last is really all you got to do, and it'll still work itself out. Okay. Next, find the conjugate of each complex number. Okay, so when you're looking for the conjugate, the thing I want you to remember is that, right, like eyes always come in pairs, right? You have two eyes. Right, everyone typically has two eyes. So eyes always come in pairs. There's always the positive one, and then there's always the negative eye. So what I'm saying is the conjugate for 7i would be negative 7i, right? Because i's come in pairs and there's always two, one positive and one negative. Hopefully that makes sense. Maybe you'll see in the next one. So take a moment and think about what would the conjugate pair for this be? Because i's always come in pairs, right? Anytime you're dealing with conjugate pairs, i's always come in pairs. They come in two, a positive and a negative. So the conjugate pair here would be 3, right? That doesn't change. Just the imaginary part changes. So 3, negative 5i. This would be the conjugate pair here. All right, fractions. So when you're simplifying a fraction, remember what I is defined as. Right? We've defined I as the square root of -1. Now, implementing that into our normal mathematic operations, whenever we're simplifying fractions and square roots, right, we don't want square roots in the denominator. Therefore, we don't want I in the denominator, because I is defined as the square root of -1, and we don't want that in the denominator. So anytime you have a fraction with a complex number that has an imaginary part, and it's in the denominator, you're going to multiply by the conjugate pair to get rid of it, right? Because I can multiply this fraction by anything as long as it's the same value top and bottom, right? Because I'm multiplying by 1. When you multiply something by 1, you don't change the value. So the conjugate pair here would be 2 positive 4i. Now, a rookie mistake, right, would be to put something on top. Right now, there's no way that this could ever work, because I'm multiplying by something that isn't 1, right? For a value to be 1, it's got to be the same number on top and on bottom, right? This whole figure right here is equivalent to 1, because the numerator and the denominator, top and bottom, are the same. Okay, so with that being said, let's simplify this out now. Now, we don't care if I is in top, right? I can be in the top of a fraction all day. It just can't be in the denominator. So watch. The denominator is going to be, so I'm going to rewrite it off to the side or down below. Okay, conjugate pair. I'm multiplying conjugate pair. So first times first. So this is going to be 2 times 2 is 4. And then I'm going to do last times last, because I already know that the other two are going to cancel. So this is going to be a negative. 4 times 4 is 16. Then I squared. I squared, I know, is -1, which is going to change the sign. So this is really 4 plus 16, which is 20. So the denominator is going to be 20. The numerator, however, is going to be 3i times 2 plus 4i. We're just going to distribute. So 3i times 2, 6i, and then 3i times 4i, which is plus 12i squared. Again, I squared is -1, and I know that's going to change the sign to a negative. So we're going to get 12, which is the real part first, -12 because of the I squared, plus 6i. Okay, check it out. We got -12 plus 6i. All right, for the most part, we're there. We're at the answer. But to be 100% complete, notice, right? All three of these terms are even. I can definitely factor out something. They're even, so at least I can factor out a 2. So if I factor out a 2, this is going to be so yes, they all are even. However, I'm going to factor out a 2 from the top, and then it's going to cancel with the number in the bottom. So watch what I'm saying. So I'm going to factor out a 2. So I'm pulling out a 2. What's left behind? -6 plus 3i over 20. And now the 2 and the 20 cancel. So final answer. -6 plus 3i over 10. Okay, now, do you have to do the last step? Yes, to be complete, right? You always want to reduce as much as possible. That's why we had a whole lesson about factoring. You want to factor as much as possible. All right. Number 6. So here, again, there's an I in the denominator. So I want to rationalize the denominator, right? I want to get rid of the square root or get rid of the I. So in this case, we have to use the conjugate pair, right? -2i. Now, really, I could have just used -i, just in this case, because there's no number in front. So because it's a pure, imaginary number in the bottom, 2i, there's no real part. I could have used just -i. But let's just stick with -2i for right now. I can go back and demonstrate that in a minute. All right, so the bottom is going to be -4i squared. I squared is -1. It's going to make this positive. So maybe you don't like it when I go fast. So this is I squared. This is really -1. So this is actually going to be +4. Right, negative times a negative is 4. All right, to the top, distributing, this is going to be -6i, and then -14i squared. Again, this is -1. So this is going to be, I'm going to write the real part first, right? So +14 minus 6i. So you always write the real part first and then the imaginary part second as the second term. Do you have to? No, but it's proper. These are all even numbers. So I'm going to factor out a 2 from the top. So this is going to be, we're almost to the final answer. So 2, this is going to be 7 minus 3i over 4. And we're going to cancel the 2, cancel the 4 to make a 2. So final answer, for real, final answer, 7 minus 3i over 2. All right, so let's see. Oh, I just want to do this one more time. So 3 plus 7i over 2i. All right, if we were to multiply by just negative I, top and bottom, right, just negative I. On the bottom, we would have had 2i squared, so negative 2. And then on top, we would have had negative 3i plus 7i squared, but 7i squared, I squared is negative 1, so it'd make this negative 7. So now notice, here, all three are negative. So really, I can factor out a negative. So, hold up. Something's not right. So, 7i times negative I would be negative 7i. Negative 7i squared. I squared is negative 1. Oh, yeah, this would have been positive. Okay. So, if I factor out a negative, because I mean, this is the answer too, right? However, if I factor out a negative 2 from the bottom, it would flip all the signs. So this would be negative 7 plus 3i over 2. Right? If you factor out a negative, right, this negative will flip all these. All right, and this only works when it's just an I term in the denominator, right? If it's just an I term, 2i, 3i, negative 4i, negative 5i, any single digit I with no real part, you could use negative I as I did right here. Heck, you could have just used positive I really, because I times I would just be negative 1. So, I mean, things get tricky, right? Like, I mean, there's more than one way to do it. However, on this last one, when it was a real part and an imaginary part, you must use the conjugate, like the real number, the real part, and then the negative part. Okay, I'll leave it at that. All right, number 7. So I can demonstrate right here. So if we just did I, right, it's a single imaginary number in the bottom. Like, so first off, the conjugate would be 2i, right? It would be 2i. But we know that I squared is just negative 1. So really, I don't really care about the 2, right? I truly don't. So I times I is I squared. So negative 2 I squared over 7i. So I squared is really negative 1. So this is going to be 7i over positive 2. Now, if you use something bigger than I, right, if I use positive 2, it'll just reduce, right? I'm just pulling it out later and factoring it out and canceling. So hopefully you all get that. Okay, so let's look at this guy. I feel like this is the pinnacle of the problem right here, or of the topic of simplifying. So there's no tricks on this one. This one is straight. We got to use the conjugate. Like, there's no easy way about it. So this is going to be square root of 2 plus 3i. Square root of 2 plus 3i. Again, we don't want any square roots, and we don't want any i's in the bottom. So let's work this out. I almost want to use negative root 2. Or negative root 2. So root 2 times root 2, that's nice. When the arguments are the same, right? The argument is the inside part. When the arguments are the same, the square roots go away, and it's just the argument. Okay, now watch. When I multiply these two, this is just going to be positive 3 root 2i. Here we have negative 3 root 2i. And then negative 9i squared. So notice here, the middle two terms still cancel. Right, I didn't necessarily have to do it, but I wanted you to see it. So again, when you're multiplying conjugate pairs, you can cancel out the middle two terms. All right, I squared is really negative 1. So the bottom denominator is going to be 2 plus 9, which is 11. Okay. Numerator. This one's easy. 7 times 2, 7 root 2. 7 times 3i plus 21i. Now, some people will argue that leaving it out, the 7 that is more simple. So you might see this answer. Now, it's all preference, right? Like it's all subjective. Like this particular topic right here is subjective. Is it more simple putting it in, or is it more simple leaving it out? Right. It's really hard to tell. It just depends on who you ask. So either one of these answers are going to be right. The answers are equivalent. So to be honest, the real answer is who cares, right? So whatever. All right. So here we go. Plotting complex numbers. Now this may seem rough, but it is not. So the x-axis, we call this the real number line. And then the y-axis, the vertical one, is the imaginary line. So we plot the real part, and then so the real part, right? The part that comes first, the part without the I. This is your left and right direction. And then the imaginary part is your up and down direction. So again, standard form of a complex number is A plus BI. And A, again, is left and right, the real part. And then the part that has the I, the coefficient, this is your up and down. So for instance, point A, we're going to go, it's positive 3 minus 2I. So we're going to go right 3 because it's positive, and then down 2 because it's negative. So right 3, down 2. So here in red, this is point A. Too easy, right? It almost sounds like, dang, is it really this simple? So negative 4, the real part, we're going left because it's negative. Negative 3i, we're going down because it's negative. So this is going to be negative 4, negative 3 in the I direction. Right, so this is, oh, my bad, this is D. All right, B, negative 2. Again, this is left because it's negative 2, the real part. Right, the real part is left and right. The imaginary part is up and down. So this is up 4 because it's positive. So negative 2, up 4. And this was B. All right, here's where it gets tricky. It's a single number, E. A single number, E. Or E is a single number, 4. Okay, 4 is the real part. So this is just, it's positive, so it's going to the right. Now notice there's no I. Right, there's no I. So I'm not going up and down. I'm staying right on the real number line, right? Because 4 is a real number. So E is going to be right here. On the real number line, because it's a real number, 4. So if you think about it, the plane, right, the complex plane, right, a plane that's made up of the real number line and the imaginary line, any number that's not on the real number line, right, because the real number line is all the numbers you've ever known, like in your entire life that you've ever dealt with. Now, any number above or below the real number line involves an imaginary part, right? It's an imaginary number. It doesn't exist on the real line. All right, lastly, C, 3i. So 3i, there's no real part. So it's going to not be on the x-axis, right? So if you start at the origin, 0 plus 0i, or 0, 0, or just 0, this is going to go up 3. So I pick a number or a color that's not, yeah. So up 3. And we'll call this C. So hopefully, no matter what complex number they give you, whether it has a real part or an imaginary part, you know how to plot it. Plotting it is easy. The real part, left and right, imaginary part, up and down. And everything behaves exactly as you think it would. Like there's no opposite or anything like that. All right, guys. Hopefully this video helped someone out. I'll catch you guys in the next video.